Hi, in this video we will do another example for the cases that a continuous random variable is a good approximation for discrete random variable. Uh, then the question asks for finding the values, writing the probability, given probabilities in terms of the other ones. Some of them are in terms of x, we have to write in terms of y, and some of them are in terms of y, we have to write them in terms of x. So here, the first thing to note is that the discrete random variable y x is evenly distributed, meaning that the um, values of x are equally spaced, and every two consecutive values are 2 units apart. So in other words, k is 2. Okay, so this being said, that means we can go ahead and do the work here. So we are looking for 6, the next value is 8, and then the next previous value is 4. The probability of x being equal to x, the 6, this is one value, but when we want to write it in terms of y, we have to turn it into an interval. And how do we do that? We go halfway up, taking it halfway up, halfway down. Halfway up here is, you see the k here is 2. Half of that is 1. So halfway up of 6 is 7. Halfway down is 5. So let me just write in more details. This is 6 minus 2 over 2, k over 2, and 6 plus 2 over 2. And that means that I have probability of y being bigger than equal to 5 and less than equal to 7. Okay, here probability of x bigger than 4, less than 10. Bigger than equal to 4, less than 10. This is very important when you deal with discrete random variables. X equality is very important. Turn all the inequalities which define the event into the inequalities with equality. So here, x is going to be bigger than equal to 4, but x only takes the value which is less than 10. It means that it won't take value 10, but the number before that, the value before that which x has is 8, so we'll have 8, then 6, and then 4 including, then the number before that we want. So only these 3 values. So this means that we are going to do this one. And now we are thickening each one of these guys to an interval. So 8 thickens halfway up, halfway down. So it will be from 7 to 9. 6 thickens halfway up, halfway down. It means from 5 to 6. And 4 thickens halfway up and halfway down. So it goes from 3 to 9. So probability of, let me just write, the lowest one with equality minus halfway up, halfway down, so 2 over 2, y, and highest one with equality, go halfway up. And this gives us probability of y is bigger than 3 and less than 9. You see, in the continuous case, it doesn't matter you put equality or not. This is the same thing as y bigger than 3 and less than 9. For continuous one, doesn't change anything. With discrete one, this is very important. Okay. Well, part 3 and 4 are the other one. It's something is written in terms of y, and then we have to find values for x whose, by thickening those ones, we will get this. So here, see, y is between 1, 2, and 3, then this is 4, and 0. So for, y is here, up here, from 1 to 3. And we know that this is the only value in this interval which you see is 2. So this will be the thickening of 2. Halfway up would be 2 plus 1. Halfway down is 2 minus 1. So it's 1. So this will be x is going to be equal to 2. How about y bigger than 7? So this is 7, 8, 9, 10, and you see that we are including all these values. When you go from continuous to discrete, it's easy. Just check what points of what values of x are there. So this will be 8, 9. In other words, everything which is bigger than equal to 8 will give you that.